We're looking at another question from the topic quadratic equations. So the question states, let x cube minus x square plus bx plus c is equal to 0 has three real roots which are in AP. We have to find which of the following could be true. So pause the video, try it yourself. In case you don't get it, then look at the solution. Okay, so here we have the cubic polynomial x cube minus x square plus bx plus c equal to 0. Now let us assume that the three roots which are in AP are a minus d, a and a plus d. So whenever we have to assume three terms in an AP, we always assume these three to make the computations easier. Now what is the sum of three roots of a cubic polynomial? It is given as minus of b upon a. A here is 1. A is basically the coefficient of x cube. That is 1. So minus of minus 1 is 1. So sum of the roots is 1. So this means a minus d plus a plus d is equal to 1. d cancels out. So we get 3a equal to 1, and therefore a is nothing but 1 upon 3. Okay. Now we know that sum of the product of roots taken 2 at a time for a cubic polynomial is minus c upon a, which is minus b in this case. So sum of the roots taken 2 at a time, which is a minus d into a plus a into a plus d plus a plus d into a minus d. So this is sum of the roots, sum of the product of roots taken 2 at a time. This is equal to c upon a, which is b here. So this is equal to b. Now if we open up the brackets, we get a square minus ad plus a square plus ad plus a plus d into a minus d is a square minus d square. This is the algebraic identity. This is equal to b. Now we can cancel this ad. So we get 3a square minus d square is equal to b. But we already computed that a is nothing but 1 upon 3. Putting this value inside the equation, we get 3 into 1 upon 3 whole square, that is 1 upon 9, minus d square equal to b. Therefore 1 upon 3 minus d square equal to b. Therefore d square equal to 1 upon 3 minus b. So I basically put d square here and b here. Now we know that the roots are real. So this means d has to be real. Now if d is real, then d square has to be greater than 0. So or greater or equal to 0. So we have 1 upon 3 minus b greater or equal to 0. Therefore taking b the other side, b is less than or equal to 1 upon 3. So this is the condition for b. Now we know that the product of roots is minus d upon a for cubic polynomial. That will be minus c. So the product of roots is minus c. Now what is the product of roots? A minus d into a plus d. This is given to be equal to minus of c. Now a minus d into a plus d is a square minus d square. We are left with the a here equal to minus c. This is a cube minus a d square. This is equal to minus c. Now we put again a equal to 1 upon 3. So 1 upon 3 cube is 1 upon 27 minus d square by 3 equal to minus c. We bring c here and d square by 3 here. So we will have 1 upon 27 plus c equal to d square by 3. Now we multiply the whole equation by 3 to get 1 upon 9 plus 3c equal to d square. Now again d square has to be greater or equal to 0 for d to be real. So 1 upon 9 plus 3c. So 1 upon 9 plus 3c has to be greater or equal to 0. So 3c has to be greater or equal to 1 upon minus 1 upon 9. We took 1 upon 9 here. So c has to be greater or equal to minus 1 upon 27. We divide the whole equation by 3. So we get c is greater or equal to minus 1 upon 27, and we had b less than equal to 1 by 3. So we get b less than equal to 1 by 3 and c greater or equal to minus 1 upon 27. So we have got these two properties now. Now we'll check which options satisfy these conditions. So b equal to c equal to 2. Clearly b is less than 1 by 3, so this is wrong. B cannot be equal to 1 again because b is less than 1 by 3, so this is also eliminated. Now b equal to minus 1, this is c equal to 1. This satisfies both the conditions. So this is true. B equal to c equal to minus 1, but c is greater than equal to minus 1 upon 27. So c can never be equal to minus 1. So c is the correct answer.